Imagine looking up at the night sky. But instead of our familiar silvery moon, you see a colossal reddish orb looming over the horizon. This isn't science fiction. It's a thought experiment. What would happen if we swapped our moon for Mars? Let's be clear. This is a visual scale disaster. We're placing Mars at the same distance the moon is from Earth, about 384,400 kilometers away. The spectacle would be breathtaking, but the consequences would be catastrophic for life as we know it. Mars is about twice the diameter of the moon. From our perspective, it would appear massive, covering an area in the sky roughly 4 times larger. The night would never be truly dark again. Mars reflects sunlight, but its surface, known as its albedo, is darker than the moon's. Still, due to its sheer size, Mars would illuminate our nights with a constant, eerie reddish glow, far brighter than a full moon. This celestial giant would dominate our sky, a constant reminder of the chaos it was unleashing upon our world. The initial visual shock would be just the beginning of a terrifying new reality for Earth. The most immediate and devastating effect would be on our tides. The gravitational pull of an object depends on its mass and distance. Mars is much more massive than the moon, roughly 9 times more, to be precise. Placing it at the moon's distance would amplify its gravitational influence on Earth exponentially. The tides, which are primarily governed by the moon's gravity, would become monstrous. Coastal cities around the globe would be in peril. We're talking about tidal waves, or supertides, that could reach heights of hundreds of meters, not just a few. Imagine a wall of water sweeping inland for kilometers, erasing entire communities. Places like New York, Tokyo, London, and Mumbai would be submerged. The familiar coastlines we know today would be completely redrawn, and millions, if not billions, of people would be displaced or worse. This isn't a gradual change. It would be an immediate and relentless onslaught. The immense gravitational forces wouldn't just affect our oceans. They would also tug and pull on Earth's crust itself. This is known as crustal tide or solid tide. Even now, the moon's gravity causes the Earth's solid surface to bulge by about 30 centimeters. With Mars in its place, the stress on our planet's tectonic plates would be immense. The number and intensity of earthquakes would skyrocket. Volcanoes that have been dormant for centuries could roar back to life, spewing ash and lava into the atmosphere. The planet would be in a constant state of geological turmoil. This continuous geological activity would have a compounding effect. The ash from volcanic eruptions could block out sunlight, leading to a phenomenon known as a volcanic winter. Global temperatures would plummet, impacting agriculture and ecosystems worldwide. Earth's very structure would be under assault from the inside out. Our once relatively stable planet would become a hotbed of seismic and volcanic chaos, making it an incredibly dangerous place to live. The gravitational dance between Earth and our new, massive neighbor would also have profound effects on our planet's rotation and orbit. Earth's day is 24 hours long, a stability we owe in large part to the moon. The moon's gravitational pull acts as a brake, gradually slowing down Earth's rotation over billions of years. When the moon first formed, a day on Earth was only about 6 hours long. With Mars's much stronger gravitational pull, this braking effect would be significantly amplified. Our day would start to lengthen at a much faster rate. Initially, the change might be milliseconds per day, but over time, it would become noticeable. This change in rotation speed would disrupt delicate natural cycles. The internal clocks of plants and animals, their circadian rhythms, are tuned to our 24-hour day-night cycle. A rapid change would throw these biological systems into disarray, affecting everything from plant pollination to animal migration patterns. Furthermore, the Earth-Mars system would be gravitationally unstable. The moon is tidally locked with Earth, meaning we always see the same face. Mars, being much more massive, would exert a much stronger pull on us. This complex gravitational interaction would likely alter Earth's orbit around the Sun. Our planet's axis is tilted at 23.5 degrees, giving us our seasons. The Moon plays a crucial role in stabilizing this tilt. Without the Moon, scientists believe Earth's tilt could wobble dramatically over long periods, leading to extreme and unpredictable climate swings. With Mars instead, instability would be gone. The wobble could become more erratic, more pronounced. We might experience drastic shifts, swinging from extreme ice ages to scorching heat waves over geological timescales, making it impossible for complex life to maintain its foothold. The very fabric of our planet's motion and climate would be torn apart. The predictable seasons we rely on for agriculture and survival would become a thing of the past. Earth would become a world of climatic extremes. Life on Earth has evolved over billions of years under a very specific set of conditions, with the Moon as our constant companion. The sudden introduction of Mars would shatter this delicate balance. The supertides would decimate coastal and marine ecosystems. Coral reefs, mangrove forests, and tidal estuaries, which are nurseries for a vast number of marine species, would be obliterated. The sheer force of the water would destroy these habitats. The constant churning of the oceans would also drastically change water temperatures and salinity levels, making it impossible for many species to survive. The foundation of the marine food web would collapse, leading to mass extinctions in our oceans. On land, the consequences would be just as dire. The lengthening of the day would confuse plants that rely on photoperiods for flowering and growth. Animals that navigate using the Moon or hunt during the predictable darkness of night would find their patterns disrupted. The reddish glow of Mars at night would interfere with the behaviors of nocturnal creatures, affecting their ability to hunt, mate, and avoid predators. The entire ecological web, from the smallest insect to the largest mammal, would be thrown into chaos. Human civilization, of course, would face an existential threat. Our infrastructure is built for the world we know, not for a planet in geological and climatic upheaval. Agriculture would fail. The combination of extreme tides, unpredictable seasons, volcanic winters, and disrupted pollination would make it nearly impossible to grow enough food to feed the global population. Widespread famine would be inevitable. Our global economy, reliant on coastal ports and stable infrastructure, would collapse. The mass displacement of populations from flooded coastal regions would create an unprecedented humanitarian crisis. The psychological impact of seeing a giant red world hanging in the sky, a constant symbol of the destruction unfolding below, would be immense. Hope would be a scarce resource in a world turned upside down. In this scenario, Mars isn't a new frontier for exploration. It's an agent of destruction. A celestial body that has fascinated us for centuries would become our doom. The beautiful, awe-inspiring sight of a giant Mars in our sky would be a fleeting spectacle, quickly overshadowed by the harsh reality of a world being torn apart at the seams. Our planet would become hostile to the very life it has nurtured for eons. This thought experiment highlights just how special our relationship with the Moon is. It's not just a pretty light in the sky. It's a vital partner that has shaped our planet's geology, climate, and the evolution of life itself. The Moon's presence has provided the stability necessary for complex life to arise and thrive. Its gentle gravitational pull has been a key ingredient in making Earth the habitable oasis it is in the vastness of space. So next time you look up at our pale, familiar Moon, take a moment to appreciate it. It's more than just a rock. It's our silent guardian, the anchor that keeps our world stable and alive. Replacing it wouldn't just change our sky. It would end our world. Thank you for watching. For more journeys into the cosmos and mind-bending what-ifs, be sure to subscribe to Space Repo.